Hi, I'm Alan Squigna at White Knight Labs, and today I'm going to do a demonstration on the use of AI technologies to analyze Windows crash dumps. This video and the associated blog is really inspired by this project and article by Sven, which you see on the screen here. He published back in May The Future of Crash Analysis, AI Meets WinDbg. Great little project. What he did is used AI's model context protocol, or MCP, to create a connection between GitHub Copilot and a large language model, or LLM, and the Microsoft WinDbg tool. Those who know of WinDbg know that it's a little bit of a difficult tool to learn and master. It's a pretty steep learning curve. It has a very esoteric kind of command language, and Sven's application really improves access, enhances access exponentially, really democratizes access to WinDbg. For the purposes of crash dump analysis, there are applications in reverse engineering, threat analysis, malware research, debugging, a bunch of different areas. So great little project. And there's also a GitHub repository that has his Python code in here. There's a great little README down at the bottom. Between the README and this video and the blog on this topic, just about anybody with a basic level of understanding of Windows and debugging and reverse engineering will find their productivity and output enhanced exponentially. So I'm going to walk through the as quickly as I can the configuration. You want to enhance your execution policies, give privilege to the running the Python scripts, with PowerShell or any other means. I've put myself in bypass mode for the session because I trust Sven, pretty good guy. So once you do that, go into launch Visual Studio Code, and we're going to clone the GitHub repository that has the Sven's project. So we'll do that, and it's going to ask you, where you want to put it. So I am going to put it up here and down into documents folder here, MCP WinDbg as my repository, and it's going to do the clone. We'll open up the project, and you can see here on the left hand side, kind of the most interesting folder is the source folder, which has a bunch of useful information in terms of the tests and some of the code. So easy so far. What we're going to do next is to set up the Python environment. So we're going to open up the terminal window and set up my Python virtual environment. So I'm going to end up fast forwarding through some of these steps, in the interest of time. And let's let that run. And then we're going to actually install the development environment and test as well. All right, that's finished. Now it's smooth sailing from here on in, actually. We can now walk over to GitHub Copilot. You want to make sure that you are in agent mode here. So that's done. Sven did all of his testing with a Claude Sonnet 3.5. So we'll switch to that, but actually you can pick whatever LLM of your choosing, and it should run just fine. So we're ready to go, actually, in terms of now using natural language to access WinDbg and that crash dump. But before we do that, there is one thing we need to check. The MCP server associated with this project should launch by itself, but sometimes it doesn't. So I'm going to just take the step to manually start the server, and I do in fact trust it. So we'll get that up and running, and then once we're there, then we can actually, for example, get our project started. Okay, so there, we've done all the necessary steps to set up. I now have an enhanced command set available to me to access WinDbg. So I can, for example, use Sven's open WinDbg dump command, right, which accesses this demo crash 7088 dump, and ask for it to access that file, access that dump file, and do at least a cursory analysis on what might have caused the crash as part of this demonstration test application. It'll take a few moments to run, so we'll let that do its work, and wait for some response. And notice that we have not launched, we have not at all launched WinDbg. So I'm going to allow for this session. Right? You don't have to know WinDbg actually to analyze a crash dump anymore. So it's certainly a good bit of an assist. If you're an expert, right, this can do a trust but verify for you. And it seems like this application was just a classic null pointer dereference situation, but with a write. It tells you write as opposed to read, which is very cool. And we're trying to write to memory location 0, which is, of course, forbidden. And we found that the AI found, just from the dump file, that RAX contains 0, null pointer. Not allowed to do that. And we tried to write hex 2A to address 0, which is going to throw an exception. So it's asking for permission to do a little bit more, and what it's wanting to do is run specific commands, and you can see more. Actually, there's the dump path down there, and let's do an allow again and run that. It's going to give me some additional context here about the crash location, the specifics there, and it's looking at the disassembly around the crash point. The end of a function. Okay, we're near the end of a function, and anyway, you can read this at your leisure. Fascinating. It gets even better. You can speak to it in plain language. So here's another command. Just look at and display the disassembly around the crash point, and give me some detail on the last 3 instructions leading up to the null pointer dereference. So that's just me writing out, okay, you said something about the disassembly. Let me look at it and give me some more specifics about what caused the crash. So it's going to run some additional instructions, and you can of course set it up for telling you exactly what instructions it's using, but you don't have to, right? And here are the last instructions, right? This of course is the crash point at which hex 2A was trying to be written into the address pointed to by RAX, which is 0. Obviously XOR of EAX and EAX, set EAX and hence RAX to 0 based on the and you've got a call instruction before that, and clearly and of course RBX was copied into our CX, right, as we're entering into we're coming to the entry point to demo crash 1 plus hex 2660. So you can see, didn't open WinDbg at all, right? Just doing a little bit of setup up front, but lots of potential here to assist someone who is an expert or get someone who's relatively new to WinDbg and Windows off to a fantastic start. Yeah, in terms of providing first level analysis, lots of potential for additional use cases and for this technology that I'll write about in the future. Thanks.